So in this chemical equation, we have aluminum sulfate reacting with calcium hydroxide and producing aluminum hydroxide and calcium sulfate. So notice we have multiple polyatomic ions. So since each of them appear one time in the reactant side and one time in the product side, we're going to keep each of them as a group. We're not going to break them apart. Now, we need to determine how many atoms and how many polyatomic ions we have present. So I have a total of 2 aluminums. I have a total of 3 sulfates. I have 1 calcium. I have 2 hydroxides. On the product side, I have 1 aluminum. I have 1 sulfate. I have 1 calcium. And I have 3 hydroxides. The next step is to identify the loner, and the loner is the one that is not part of a compound. In this chemical equation, we do not have that, so we're going to bypass that step. The next step is to identify the 1:1 ratio, also known as the pair element, and that would be the one that appears one time in the reactant side and one time in the product side. So it happens to be that each of our products that we have appear one time in the reactant side and one time in the product side. So aluminum, 1 and 1, sulfate, 1 and 1, calcium, 1 and 1, hydroxide, 1 and 1. So now we need to start with the largest 1:1 ratio, also known as the pair element, and this would be the one that has the largest subscript. So notice that we have sulfate and we have hydroxide, and they both have a subscript of 3. So in this chemical equation, regardless of which one you start with, they're both going to give you the same answer. So let's see, when we start with this, we have a total of 3 sulfates. And then over here, we have only 1 sulfate. So what I want to do, I want to change this into a 3. But first, I need to write a coefficient of 1 over here because 1 times 3 gives me 3. So I locked in this compound. Now I can come to the product side and I can say that I have 3 coefficients, 3 sulfates. And I'm going to change that to a 3. Next, I'm going to continue with this because this 3 is going to make a change for the calciums. So I have 3 calciums. So therefore, when I come to the reactant side, I need to have 3 calciums. And the way that I change this to a 3 is by writing a coefficient of 3 here. By the way, we have balanced the sulfates. We have balanced the calciums. Now that I wrote this 3, we now have 3 times 2 equals 6 hydroxides. So if I have 6 hydroxides in the reactant side, I need to have also 6 in the product side. So the way that I do that, if I have 3 right now, I'm going to write a coefficient of 2. Because 2 times 3 gives me 6. And we have balanced now the hydroxides. Now it's a matter of checking the aluminums. We have 2 and 1, but with the new coefficient, we now have 2 aluminums. And over here, we also have 2 because 1 times 2 makes 2. So at this point, everything is balanced.